Hello, back with another video from 21 and 21. This time it's from the disaster recovery series. This was pretty highly requested in the Discord for what project people wanted. So you have made a series on it, looking at disaster recovery for multi-region. That's the first project in the series. CloudFront failover, and then multi-cloud with Pulumi is the final part of the series. But we're going to start, like I said, with multi-region apps on AWS. So we're going to deploy your web app to multiple AWS regions, like big companies like Netflix do, with GitHub automatic deployments and instant failover readiness. So this is a pretty easy project. Should take about 45 minutes. Likely take me about an hour, but longer, because I'm speaking out loud and explaining stuff. And then the related projects here are part 1, one we're doing now, part 2 and part 3. So that's the CloudFront failover and the multi-cloud with Pulumi. And some key concepts here are AWS App Runner, AWS Regions, GitHub, and Express.js. We'll touch on what these are shortly. Awesome. Okay. So our 30-second summary. Your app runs in one AWS region. That region has an outage. Your users get errors. You scramble to manually deploy somewhere else while your phone blows up with alerts. This is what single region deployment looks like under pressure. Now imagine your app is already running in 2 regions. When one goes down, traffic routes to the other automatically. No scrambling, no manual intervention, no 3 a.m. firefighting. Your users don't even notice. Companies like Netflix, Uber, Airbnb deploy across, really any big company will deploy across multiple AWS regions, serve hundreds of millions of users with a 99.99% uptime. Netflix famously runs their active across regions, so any region can handle full traffic at any time. This is how they survive outages without customers noticing. So you'll build the same foundation, a web app deployed to multiple AWS regions with automatic deployments from GitHub. This is the first step toward true high availability, and you'll complete the picture in the next project by adding automatic failover. So what you'll build in this project, you'll deploy a Node.js app to AWS App Runner in 2 regions, US East and US West 2. US East 1 and US East 2, West 2. So if you're new to App Runner is AWS's fully managed container service that makes it easy to deploy web apps without managing servers. So gaming companies, fintech startups, enterprise teams use App Runner to deploy microservices that scale automatically under load. You push code to GitHub and App Runner automatically builds, deploys, and scales your app with HTTPS included. No load balancers to configure, no servers to provision, no certificates to manage. You write code, push, and it's live in minutes. This project doesn't require any prior AWS experience. You'll learn how App Runner works, how to get set up, how to set up automatic deployments, and how to deploy the same app to multiple regions. The foundation for production-grade resilience. So prerequisites, pretty much just having an AWS account. There's a project on how to set that up for free here we've made. So go and check that out if you don't have one. Cool. Okay. So if you're not sure if this project is for you, feel free to use the Ask feature here. Ask our AI to see if it's correct for you. Just jump straight into it. How you'll build it. So first you'll create a simple Express app and push it to GitHub. Then you'll deploy it to the App Runner in US East 1 with automatic deployment enabled. Finally, you'll repeat the process for US West 2 and make the app region aware so you can tell which region is serving each request. This is sort of a outline. So you've got the developer, push it to this GitHub repo, and then users will go to whatever one they'll be able to see what they've got. Based on the text on the screen, and we are going to do the secret mission. The secret mission involves adding something which shows how long the response time, the round trip response time for users are for both of these locations. So it will also, if we do the second mission, show that in here. Cool, so by the end of this project, you'll have a web app running in 2 AWS regions with automatic HTTPS, automatic deployments from GitHub to both regions, region-aware responses showing which region is serving each request, and the commissioner's latency measurement to see why multi-region matters for performance. If you're up for a bit of a challenge, you can quiz yourself first. We're going to do this at the end, but you're welcome to do it at the start as well if you're following along. Choose your mode. We offer 3 different modes. I'm going to go through high guidance, step-by-step guidance, but you're very welcome to go through either low, which has just the explanation steps there, or no, which has just the explanation steps, or low, which has more of an outline. Cool. So in step 0, before we start step 1, let's think about what we are building in this project. In this project, I'm going to deploy a web app to AWS App Runner in the east and west, east 1, US East 1 and US West 2 regions. Multi-region architecture matters because it provides redundancy. So that's if one goes down, the other still users can still use the other. So what are we doing in this project? In this project, I'm going to deploy a web app to AWS App Runner in the US East and US West, US East 1 and US East 2 regions. Multi-region architecture matters because it provides redundancy. If one server goes down, users can still use the other. Use the site hosted on the other. Cool. So step 1, we're going to launch our app in US East 1. Time to get your first region live. You'll deploy a Node.js Express app to AWS App Runner in US East, which is in Virginia, the same region that hosts Netflix primary infrastructure, with automatic deployments from GitHub. Every code push goes live within minutes. So in this step, you're going to create a simple Node.js app, deploy to AWS App Runner, configure GitHub integration for auto deployments, verify your app is running with a public HTTPS endpoint. Cool, so what are we doing in this step? In this step, I'm going to create a simple Node.js Express app, deploy it, we can say. I'm going to deploy it to regions. This sets me up to do, we spoke about it up here, automatic failover. Awesome. What are we doing in this step? In this step, I'm going to create a simple Node.js Express app, configure GitHub for automatic deployments, and verify everything is running, I'm going to deploy it to multiple regions. This sets me up to do automatic failover. Next. Cool, sounds good. So we're going to create a GitHub account. First, let's set up GitHub to store your code. AWS App Runner will pull from this repo and deploy your app. Cool, so we'll go to GitHub. So we're going to go to github.com. I'll just open this up over here. I can sign out just to walk through the flow. So we can click sign in or sign up. I already have a GitHub account. If you don't, there's steps to go through here to create one. But I already have an account, so I will just sign up. I'll just move this off here for a second so I can do that. But yeah, just sign up to GitHub. There you go, or logged in. Awesome. Cool. Okay, so we'll go over to repositories. We'll click the new button here, and we'll name the app multi-region app. Don't need a description. We'll set it to private, and then we'll click create repository. Copy that, paste that in there. Awesome. Okay, so let's check if we have Cursor installed. So we'll open up, let's make that bigger, and we'll run this command. Cool, we see it, so that's great. See a version number that you can go to open Cursor, but if you don't, then there's some installing steps here. So I see a version number, so I'm going to close this, and then I will go and open Cursor. Can take a second on my machine to do that. Take too much longer. And we're just going to clone this repo into Cursor when it opens. It's just open now. Cool. Move it over here. It wants to drag. There you go. We'll go like this. And if you're already in an application, then that's fine. This will still work if you've opened something up. You already have a project open. So we'll go on Windows. We'll go Control-Shift-P. We'll select Git clone, and then we'll copy our. Thing in there. Then, oops, one second. Sorry about that. I'm going to Git clone. Clone from URL. We'll just select our desktop. Cool. So choose a folder, like your desktop, to save the project to, and when prompted, click open to open the clone repository, we'll be taken to the empty cursor page here, which is good. Alright, so let's create our Express app with AI. So now let's use Cursor AI to create our Node.js Express app. Instead of writing code manually, we'll use prompts. So we're going to open the cursor chat using Control L on Windows. I'll zoom out a little bit. And then we'll paste this prompt in. Cool, so we can read this prompt while we wait for it to work. Create a simple Express app. I can deploy an AWS App Runner. I need a package.json, so that's an install list, requirements list of packages that need to be installed for this to work. And then an index.js that listens on a specified port, or 8080 as a fallback. And then just a single route, which has one page, one bit of text, which says hello from AWS. Cool, so what did Cursor create? Cursor created two files, package.json, your project manifest that lists dependencies like Express, and index.js, a minimal web server that responds with hello from AWS. The process.env.port, or 8080, just the two bars. Pattern is important. It lets App Runner automatically provide the port environment variable, so you don't need a .env file. And then the or is the fallback, the two bars, or pipes, sorry. Cool, okay, so we should be able to, now we've got this stuff, we can go open a new terminal. You can do it that way, or you can do it the way that's specified there. Control, like apostrophe, to open it up. Then we can do git add, git commit. Could just copy the commands, but oops, not gonna update. Oh well. Oh yeah. Git push. Cool. So that's all pushed up. If you see any sort of authentication error, I actually ran into this a minute ago. I was logging the wrong Git account, so I switched. That's why I brought cursor off the side of my screen. But yeah, push succeeded, so that's good to go. We can actually go look in our browser to make sure that this Git repo has the components. So you can see here, I spelled app wrong. Oops. But we can see index.js and package.json in this file, and all ready to go. So, and this is the code we were speaking about here, which has the fallback port, and then just the effective landing page, and then a effective landing page saying hello from AWS. So we're hosting it for now. Stay tuned for other platforms. GCP will be involved in the last project, and then there's a console log to make sure we know what port we're on. Cool, so that looks all good. Nice. So let's upload a screenshot of our repo. Just put this back over here. Oops. Open up my screenshot tool. Then we'll just paste that in here. How did you push your code to GitHub? I pushed my code by running git add commit then push. GitHub stores my code so that AWS App Runner will be able to automatically deploy new code on push. How did you push your code to GitHub? I push my code by running git add, commit, then push. GitHub stores my code so that AWS App Runner will be able to automatically deploy the new code on push. Maybe any. Awesome, let's go deploy to AWS App Runner. So now let's deploy your app to AWS App Runner in US East 1. So we're going to go to the console. I will be using a other Chrome browser for this. Load. So I'll just put this over top here. Cool. So we'll search for App Runner in the console. Search. Select this. And yeah, now's a good time to make sure you're in US East 1 for this first one and US West 2 for the second. We'll break it up then too, but definitely want to be in the right region. So we're going to click Create a Service. For source, we'll do source code repository. Provided GitHub, that's good. Click Add New and create a GitHub connection. So we'll select Kahubit because that's the one that I need for this. Connection name, we'll just call it GitHub Connection East. We can install another here. Continue with this. And then we can go only select repositories. Then we can do multi-region app and click authorize. Install and authorize. Okay, I've got to verify my email. One moment. Where's that pop-up on? There we go. Cool. Looks good. It will often give an error here and say this, which is a strange thing, but it is actually okay. It's not like an issue. We can see that if we refresh the page. But yeah, it's a bit odd. We'll refresh and see what happens. Yeah, so that worked. So that happens to you. Don't worry. That's a normal thing to happen. It would appear for some reason. And we'll select automatic deployment. So every time something's pushed to this repo, it just deploys. So what actually is AWS App Runner? App Runner is a fully managed container service that runs your web applications without you managing servers. You give it your source code and it handles building, deploying, and scaling, and load balancing automatically. The automatic deployment setting means whenever you push code to GitHub, App Runner detects the change and deploys your app. No manual intervention needed. This is CI/CD, continuous integration, continuous development built right in. Cool. So now configure some build settings. We'll choose the runtime as Node.js 18. We'll do a build command as npm install, so that's installing all the stuff in our package.json we've just uploaded to our GitHub, which this has access to. We'll do npm start to start the app, and then port it to 8080. It's good. So all these build settings, like I just said, npm install downloads all your dependencies before running the app. The start command, npm start, tells the app runner how to launch your application. It runs the start script from your package.json. The setting 8080 tells app runner which port your app listens on so it can route incoming traffic correctly. App runner also automatically provides HTTPS with a valid SSL certificate. No configuration needed. Awesome. Very good. So we'll choose the service name of multi-region app east. The other will be west. And those CPU and RAM settings are totally fine for what we're doing. Cool. Don't need to configure anything in security or tags. It's fine. You get a little preview of everything here. You just scroll down to the bottom and click create and deploy. Awesome. Cool. This shouldn't take too long. Should take about 2 to 3 minutes. What happens during deployment? App Runner is doing several things behind the scenes: cloning a repo, running npm install to fetch dependencies, bundling your application, and launching it in a managed container. It also provisions a load balancer, configures auto scaling, and sets up health checks. All of this infrastructure that would normally take hours to set up manually happens automatically. So it take hours to set up manually. That happens automatically in minutes. So shortly we'll see a green message up here, and that means our deployment succeeded. It can take 3 to 5 minutes to actually go ahead and do that. But yeah, we'll just wait around, and then once it pops up, we can visit the web app. Okay, I just refreshed and it says running. So I missed the successful deployment banner, but it's okay. So hopefully when we go to this link, it should have, there you go, hello from AWS. So that's the code that Cursor wrote for us, and it's on US East 1. You can see it matches up with that. Cool. So we'll take a screenshot of this. Upload it here. How do you verify your app is running? I verified my deployment by to my live domain. And checking it has hello from AWS. App Runner automatically provides. We had a list of stuff before, so HTTPS and TLS/SSL certificate. Cool. How did you verify your app was running? I verified my deployment by going to my live domain, which is that, and checking it has hello from AWS. App Runner automatically provides HTTPS and TLS/SSL certificate, which is the reason why it's HTTPS, not just HTTP. Cool. So I see hello from AWS. You don't. There's some steps here. Yeah, definitely recommend reaching out to our community, as well as using the Ask feature over here. If you had any questions, it's got all the information about this project. So yeah, definitely recommend that. Cool. So now we're gonna do a similar thing in Oregon to get that second thing running. So expand to Oregon or US West 2. Your app is running on the East Coast. Now let's put it on the West Coast too. This is the foundation of multi-region architecture, the same pattern Netflix uses to serve 200 million users. When US East 1 goes down, and it has, US West keeps serving traffic. That's real redundancy. So you'll follow a similar process to step 1, just in a different region with a new GitHub connection. So in this step, you're going to deploy the same web app to AWS App Runner in US West 2, create a new GitHub connection for the second region, verify both regions are running simultaneously. So what are we doing in this step? In this step, I'm going to deploy the same web app to a different region, US West 2. Each region needs its own deployment / GitHub connection because it needs to be able to pull the code to deploy it from GitHub, because they each need to pull the code from GitHub. It needs to be able to pull the code to deploy. Let me say they each need to pull the code from GitHub to deploy from the GitHub repo to deploy. Cool. So what are we doing in this step? In this step, I'm going to deploy the same web app to a different region, US West 2. Each region needs its own deployment / GitHub connection because they each need to pull the code from the GitHub repo to deploy. Awesome. Cool, so let's switch to US West 2 so we don't create the same thing we just did. We go US West 2 in Oregon. Cool, so I selected that, and you can see the service is gone because we're not hosting on that. We're hosting on US 1, that's what we created the previous one. So why US West 2? US East 1 and US West 2 are 2,500 miles apart. A disaster in one won't affect the other, plus West Coast users get a 50 millisecond response time from the US West 2 versus 150 milliseconds from US East 1. So we're going to create an App Runner service in US West 2. We'll navigate to App Runner and click Create Service. Again, we're kind of already there, but we'll go App Runner. Open it again. We'll click Create New Service. Again, for source, select GitHub repository. It should fill this in. And once that loads, it should show us, refresh it, some old stuff in there. Cool, okay, nice. So we can click Add New GitHub Connection. We'll go as the same Git account. We can enter a connection name here, so I'll just paste the one we had in before, and then change that to West. Then we'll click next. Might give us the same things that it did give before. That's fine, it should work. We'll refresh this page. Cool, good to go. We'll select automatic again. Runtime, same Node.js 18, same npm install, then npm start here. So why do I need another GitHub connection? AWS resources are region specific, so US West 2 can't see any resources in US East 1. Each region needs its own connection, and this isn't theoretical. In 2021 and heaps of times since, or heaps, maybe once or twice, US East 1 went down for 7+ hours. Netflix, Disney Plus, Slack went all offline. Companies with multi-region, the US West 2 kept kept serving users. This is a really big deal when this happened, and it has happened since. So this is really good practice, and yeah, not just theoretical. It's yeah, readily applied. Cool. We'll call this multi-region app West. Click next. Review our settings, and then we can click create and deploy. Again, we'll have to wait between 3 and 5 minutes for this to deploy, because if I go to this, right now it'll just have site can't be reached because it hasn't deployed yet. So that shouldn't take too long. We can answer this now. Why did you create a new GitHub connection for US West 2? I created a GitHub connection named what do we actually call it? I think I had it here. Actually, I don't even think I called it -GitHub. I think I just called that. Because this makes it clear what connection, well, where the GitHub connection is pointing. AWS resources are. Let's see if that. Ask the ask chat. So the ask chat's a really great feature that you can use if you're stuck and you don't understand something, or just want to more, yeah, give yourself a bit more confidence when answering a question. So in AWS, a resource is essentially any entity or component you work with within the cloud environment. That could be e.g. App Runner. Cool. So why did you create a new GitHub connection for US West 2? I created a new GitHub connection named multi-region app West because this makes it clear where the GitHub connection is pointing. AWS resources are spaces/entities within the cloud environment, e.g. App Runner. Cool. So now we'll just wait for this to deploy. Should take another minute or two. And then once that's done, we can go verify both are running. Cool, so we can see that's been deployed. So we can load this. See if that wants to refresh. Not yet. refresh. Oh, refresh maybe. Okay, we're good. So both on West 2 and East 1, we get the same hello from AWS. Oops. Cool. Awesome. Tentative content. But how do you know which region is responding? Let's fix that in the next step. So I'll just take a screenshot of both of these side by side. What benefits does multi-region provide? Oh, scroll around a bit. I verify both regions by going to each URL and checking if they both had hello from AWS. Multi-region provides redundancy and latency benefits. What benefits does multi-region provide? I verified both regions by going to each URL and checking they both had hello from AWS. Multi-region provides redundancy and latency benefits. What is multi-region architecture? Identical app copies in separate regions equals high availability. One goes down, the other keeps running, plus lower latency. The user hit the closest region. Netflix and Uber use this for 99% uptime. Is multi-region worth the cost? You're now paying double the infrastructure. Not everything needs to be this payments systems. Yes, internal admin tools probably not. Always weigh cost of downtime versus cost of redundancy. Very correct. So if it deployed, that's great. If it didn't deploy, there's some steps here, some common issues, deployment logs there. In my case, I just needed to refresh it, but yeah, you might need to do more than that. And obviously reach out to the community as well, Discord community, and use the ask feature here if you get stuck. Yeah, but we're ready to go on to the next step, which is region detection. So both regions are live, but how do you know which one is responding? Right now they return identical messages. You can see the URL, but still, you could replace that with not US East 1 very easily, and then someone wouldn't know which to go to. So let's make your app display which region is serving each request. This is essential for verifying failover works correctly. And it's how production teams debug routing issues. In this step, you're going to update the app to display the current AWS region, push changes, and watch both regions auto-deploy, and then verify each region shows the region name. So in this step, I'm going to update the app to read and display region names of the host of where the site is being hosted, so that I can tell which site to go on. Gee, if I was closer to US West 2, I would go on US West 2. Cool. Very good. What are we doing in the step? In the step, I'm going to update my app to read and display region names of where the site is being hosted so that I can tell which site to go on. E.g., if I was closer to US West 2, I would go on US West 2. Update your app code with AI again. So AWS App Runner automatically provides the environment variables to your app. Let's use Cursor to create the updates. Actually, I'll send this prompt off so we can save some time. So what are environment variables? Environment variables are values that exist outside of your code but can be read in your application at runtime. They're perfect for configuration changes between environments, like which region you're running in, database connections, strings or API keys. So using process.env.variable name in Node.js reads these values. App Runner sets AWS region automatically, so you don't have to do anything. So your code always knows where it's running without hard coding anything. Cool. So we can see there, region, we're setting the variable to process.env, which is where what they're hosting it on, same as port. And then, so AWS region is what they're hosting it on, and .env is the file, or just having a fallback to local, which is cool. Cool. So we send that prompt off. We got our response. And what did Cursor change? Cursor added a line to read AWS region, the AWS region environment variable, no.env needed. App Runner automatically sets that to whatever it is. The local fallback is testing on your computer, is only for testing on your computer where AWS region won't exist. Same code, just wouldn't break. Different output depending on where it runs. Cool. So again, let's control and open up terminal, control apostrophe, and then I will run these commands here. Cool. So run that. How does automatic deployment update both regions? I use Cursor to update the index.js file. This I added AWS region support. The AWS region variable is set by AWS themselves, which is AWS, so that on runtime I can use process.env.aws region to set a dynamic variable on of the region name. Automatic deployment means that after we push our code, the deployment automatically starts. Cool. So how does automatic deployment update both regions? I use Cursor to update the index.js file. I added AWS region support. The AWS region variable is set by AWS, so on runtime I can use process.env.aws_region to set a dynamic variable of the region name. Automatic deployment means that after we push our code, the deployment automatically starts. Great. Cool. So because you configure automatic deployments, like we just discussed, both App Runner services will detect the change and start deploying. How does automatic deployment work? When you push to GitHub, App Runner's GitHub integration detects the new commit and triggers a deployment in both regions automatically. Each region independently pulls your code, builds it, and deploys it. This is continuous deployment in action. Code changes go from your laptop to production in minutes without manual intervention. Both services watch the same main branch, so they're always in sync. Awesome. So we'll go back to our AWS console and just check everything's being deployed. Just go over here and refresh. This one's still being deployed. Actually, the other one is as well. We can go to console home, then go to East 1, go to App Runner here. Yep, still deploying. So in US West 2, your multi-region app West service should show a new deployment in progress, which it does, which is great. And US East 1, your multi-region app East service should show a new deployment, which it does. So Yeah, both of these are just whirring away. Should take 2 to 3 minutes, maybe a bit longer to deploy. So we'll just wait for that. Cool. So our 2 regions have deployed. So we can go visit both of these. See that west is from west 2 and east is from east 2. So hello from east 1, hello from west 2. Very good. So we'll just take another screenshot of this before. There. Why is region visibility important for production? I verified region detection by adding the AWS region the site was being hosted on hosted after text. This matters for failover because I need to be able to determine which region has failed to update traffic routes. Cool, so why is region visibility important for production? I verified region detection by adding the AWS region. The site was being hosted on, the site was being hosted on, no comment there, after the text hello from. This matters failover because I need to be able to determine which region has failed. We won't be publishing this on the failover, but we'll need this variable when we're doing it, the failover project, later in the series. So now you can clearly see which region is serving each request. This is crucial for testing failover scenarios in the next project. Why does region visibility matter? Knowing which region serves each request is essential for debugging and verifying your failover setup. In production, you typically log the region to your monitoring system rather than displaying it to users, I just said. But if we set this up to highlight the location during development and testing, hello from US East 1 or West 2, it instantly tells us which path the traffic took. So it's great. So this worked. If it didn't, there's some steps here you might not have pushed, might not have waited long enough, might just need to refresh. Also reach out to the community as well, or use the ask feature over here whenever you need it. Awesome. Okay, so let's look at the secret mission. Measure real-world latency. So how do companies like Netflix, Spotify, and Amazon decide which region to route each user to? They measure latency continuously. The closer your server is to the user, the faster their experience, and milliseconds really matter. Amazon found that 100 milliseconds of latency costs 1% of sales. So in the second mission, you add response timing to measure the real performance difference between your regions. The same techniques, CDNs, used to route the users to the fastest origin. Cool. So in the second mission, you're going to measure what really happens in multi-region latency, multi-region latency. You add response timing to your app to see the real performance between the different AWS regions. This is the same technique CDNs like CloudFront use to route users to the fastest server, and it's why companies like Amazon obsess over milliseconds. Why does latency matter? Every millisecond counts for the user experience. Studies show that 100 milliseconds can reduce conversion rates by up to 7%. When your app runs in multiple regions, you can route users to the closest one, but first you need to understand the latency landscape. That's what we're measuring here. So in the second mission, get ready to add servers, response timing to your Express app, measure round-trip latency from your location to both regions, understand why multi-region architecture reduces latency for global users. So in the second mission, I'm going to measure round-trip latency. Latency matters because it can decrease the conversion rate of your web application. And we've got the example of AWS. So what are we measuring in the second mission? In the second mission, I'm going to measure round-trip latency. Latency matters because it can decrease the conversion rate of your web application, e.g. AWS sales. Cool. Let's add response timing with AI. Let's use Cursor AI to add timing information to your app. Open the Cursor chat panel, Command L or Control L on Windows, and then send that prompt. We already have this open. Okay, we can put in our URLs here as well. So East 1, go there, and then West 2 can go here. We can paste that and then put that into Cursor. We can have a little, while that loads, we can have a little talk about what this is actually doing. What does this measure? Performance now is a browser API that returns a high precision timestamp in milliseconds, so just capturing the current time. By capturing timestamps before the request, you can calculate how long the request actually took. This code tracks two things: server processing time, how long the server took to generate the response, usually 0 to 5 milliseconds, and then round trip latency, the total time from request to response. You'll measure this in the browser. The difference between these shows how much time is spent on the network, the part of multi-region architecture, the part that multi-region architecture optimizes. Cool, so we're just seeing this go through now. Cursor's making some changes. Cool, okay, so again, we will use our automatic deployment, and we'll just git add, commit, then push, and then we should see these two regions start deploying again. So we'll go to the AWS console and check both App Runner services, US West 2 and US East 1. Which take a second to pop up. There you go. So again, we'll just hopefully it'll deploy. Shouldn't take too long. Take 3 to 5 minutes to go through and deploy here. So yeah, cool. So we can see our projects have been deployed. This one's still, there you go, flipped over. So open up these two, this one over here, just refresh them. Cool. Zoom this one in a little bit so we can get even. Yeah, I'll read what it says here. So deployed, that's all good. Let's measure latency. Awesome. So we can see here, I'll put some screenshots of this in a second, but we can see that the two regions have sort of reflective response times. US East 1 here, 210, 214, similar enough. West 2, 168, 177. So clearly I'm closer to West 2 than I am to East 1, and that response time will it will always change a little bit. But if you if I refresh these pages, they might update to big numbers. Yeah, there you go. There's an example of something a bit of latency error, but pretty similar in the grand scheme of things. So that's cool. How does your app measure latency? I added timing by taking a time delta using the it is performance now. Setting performance to grab the current time. Compare this with code measures round trip time. So using cause headers to identify which server we are hosted on. Cause headers, and that they both use with AWS region to identify which server we are hosted on. Cool. How does your app measure latency? I added timing by making a time delta, by taking a time delta using performance. Let's say performance now. This is a web API to grab the current time and compare. Full stop there. And compare this with the time when loaded. The code measures the round trip time using cause headers with AWS region to identify which servers we are, which server we are hosted on, which server. Yeah, we're hosted on. That's fine. Cool. Measure latency with browser dev tools. So now let's measure real latency with location to each region. Cool. So what are browser dev tools? Measure tools every modern browser. The network tab shows the HTTPS requests the browser makes, including time breakdowns. You can see how long a DNS lookup took, how long the connection took to establish, and how long the server took to respond. This is sort of a bonus exercise here, but we can have a quick look, but really not super important. In the network tab, we refresh, we can see sort of the length of these responses here, and that's cool. But yeah, really, this is a verification step to make sure that what we've got going on here with these numbers is correct. Yeah, that makes sense to me. So yeah, we're seeing about 100, 200 milliseconds there, and then about another 300 there. So that's that's very good. You can see different region responses. At different points, you can move these, sort of drag those around. So understanding your results, now that you've measured real network latency between your location and AWS, what affects latency? There's physical distance, there's networking hops, so each router adds a small delay, internet exchange points, traffic crossing between them, also adds latency, time of day, network congestion. It's a really high load part of the day, just like the power grid. It'll the amount of content on there will be high, so it's harder to efficiently route traffic. This is why physics can't be optimized away. The only way to reduce latency for users worldwide is to put servers closer to them. The typical patterns you might see in New York, San Fran, and Tokyo, these are some typical values. If you want some advanced stuff, you can test latency variables globally. Try these free tools, all pretty good. So enter your App Runner URLs and see how latency varies from different parts of the world. This is exactly what CDN routing, like Cloudflare, do. So what do CDNs use latency? How do CDNs use latency data? Content delivery networks like CloudFront continuously measure latency between their edge locations to your origin servers. When a user in Tokyo requests your app, CloudFront knows US West 2 has a lower latency, so they choose that. It's called latency-based routing. So what latency values did you observe? US East 1 was around 214 milliseconds, nanoseconds. US West 2 was 195 milliseconds. The closer region had a lower latency because the round trip distance is shorter. We can optimize away physics. Cool, so secret mission complete. We've learned how to use performance now to measure timing on a browser, why physical distance creates unavoidable latency because it can't be optimized away, and how browser dev tools can be used to analyze performance, and why multi-region architecture is essential for serving global users. Awesome. So I'm going to keep all this stuff because I'm doing the next project, but I will go and do, if you want to remove stuff, you can go down here, remove services or local files, but I'm just going to keep filling out validations. The key tools I used include AWS App Runner and Cursor. Key concepts I learned include redundancy and latency. How long did this project take you to complete? The project took me approximately, say, 1 hour. The most challenging part was waiting for the AWS deployments to finish. Took a long time. It was most rewarding to see the response time match in the browser to the web page. Cool. Next in this project, why did I do this project today? I did this project to learn how to set up multi-region for disaster recovery. The skill I want to learn is CloudFront failover. That's the next project. Cool, so we'll quickly do the quiz. In a Node.js Express app, what is the purpose of that? Configures application to automatic scale. It allows traffic app runner port. It specifies that application should only be accessible on port 8080. You should always listen to 8080 regardless of the environment. It allows the application to use custom port for local testing, while App Runner automatically provides port. Allows the application to use custom port for local testing, while App Runner automatically provides port environment variable. Application to automatically scale based on port. Specifies that. I think it's this one. Cool. When configuring AWS App Runner with GitHub integration, what happens when new code gets pushed? The developer App Runner takes change or redeploys the application. Right to me. What is the main reason companies like Netflix and Uber adopt multi-region architecture to achieve high availability, lower latency, simplify deployment, to enable manual server management, to reduce infrastructure costs, definitely higher availability and lower latency for users. Why is a new GitHub connection required for each AWS region? Because AWS resources, including GitHub connections, are region specific, to allow different GitHub accounts, to enable manual deployment, GitHub security policies, because AWS resources, including GitHub connections, are region specific. Yes. How does an application running on AWS App Runner typically determine which AWS region? By hard-coding region name, by reading AWS region environment variable. Cool. What is the primary benefit of using AWS App Runner for deployment? It provides direct access to EC2, automatically handles building, deploying, and scaling. Awesome. That's this project done. So I hope you guys really enjoyed. It's a great project. I think there's plenty to learn in this space, and I think the rest of the series is so cool. So yeah, super stoked to be working through this, and yeah, I really hope you guys enjoyed the project. See you next time.